question, and we are going to discuss one important question from this chapter called arithmetic progressions. So you guys are very familiar with this chapter, and as you guys know, we just have two important equations from this chapter. Okay, so let's see one important question from this chapter, and through this single question we are going to discuss all the important topics from this chapter. Okay, so even if you are skipping this whole chapter, don't skip this question, because we are going to see all the important concepts from this chapter through this single question. Okay, so are you guys ready for the question? Let's see that. So you can see this question. Kavya put rupees 100 into her daughter's money box when she was 1 year old. Okay, so we have this Kavya and her mother. Kavya's mother is putting rupees 100 into her daughter's money box when she was 1 year old. So when she was 1 year old, mother is putting 100 rupees. Okay, and then in the second year, that is on her second birthday, mother is putting rupees 150. So on her second birthday, it is 150. On her third birthday, it was 200. Okay, and so on. The question is, how much money will she put in the money box on her 21st birthday? So when it is her 21st birthday, how much money this mother is gonna put inside the money box? Also, how much money will be collected in the money box by the time her daughter is 21 years old? So you guys know this. We just have two equations and we are going to use those two equations here. Okay, so first question here is this given sequence an AP? So we have this 100, 150, 200, etc. Is it an AP? When can we say that a given sequence is an AP? Yes, you said it when this has a common difference, right? When A2 minus A1 is equal to A3 minus A2 is equal to etc. Right? So the first term here, this is known as A1. The second term here is A2. The third term here is A3 and etc. Depending on the position, we are giving names A1, A2, A3, etc. Right? Then how do we check for this common difference? Yes, always do this one, A2 minus A1. What is that? It is 150 minus 100, which is equal to 50. Okay, again find A3 minus A2. Here it is 200 minus 150, again 50. So this sequence is an AP. Why? It has got a common difference, or we call it as D. So here D is equal to 50. Okay, and usually we call the first term as A. This is A1, but we call it as A. So this is an AP with A is equal to 100 and D is equal to 50. Okay, we have an AP with A is equal to, the first term is equal to 100 and the common difference D is equal to 50. Okay, now what we have to find? Let's do the first part of the question. How much money will she put in the money box on her 21st birthday? So what we have to find? The amount of money that this mother is putting into this money box on her 21st birthday, or mathematically, or in terms of AP, it is A21, right? Okay, so we need to find A21 first. How do we find the nth term of an AP? Here comes the first important equation from this chapter, that is an is equal to a plus n minus 1 into d. Okay, what is this n? Which term we are considering here? Yes, we are going to find A21. Therefore, n is equal to 21. Okay, then what is A? It's the first term. It's 100. Then what is D? D is equal to 50. Now can we find A21? Yes, of course we can. So A21 is equal to A plus n minus 1 into D. Okay, let me write an first. An is equal to A plus n minus 1 into D. Therefore, A21 is equal to 100 plus 21 minus 1 into 50. Okay, so this is gonna be 100 plus 20 into 50, which is 100 plus 2 into 5 is 100. No, I mean 2 into 5 is 10, then 1 0, then again 1 0 we have to put, right? Okay, so 100 plus, instead of multiplying 20 and 50, you are going to multiply 2 and 5, which is 10, then 2 zeros you have to put, right? Okay, so this is equal to 821, or the amount this mother is putting into this money box on her 21st birthday. Is the question over? No. Here we are introducing the second important equation from this chapter. So read the question. How much money will be collected in the money box by the time her daughter is 21 years old? So what is this? Yes, this is the sum. Okay. First year it is 100 rupees. Second year 150. Like that, on this 21st birthday she is putting this much amount. So the total money that has got collected in the money box, right? So we are going to find S21, or the sum at the end of this 21st year. Okay, so S21 is equal to, before that, what is SN? Sum of first n terms of an EP is given as n by 2 into 2a plus n minus 1 into d, right? But we have one more equation, right? If the last term or the nth term is given, yes, we have this as n by 2 into a plus an. Okay, we have two equations. So let's see both these equations through the single question. So here, okay, when you are using the first one, I'm going to use this one, that is n by 2 into 2a plus n minus 1 into d first. Let's forget about the second one. Okay, so I'm going to use the first one here. So what is n? I need to find S21. So n is equal to 21. What is a? A was the first term. As you can see here, a was 100 and b was 50. So a is equal to 100 and d is equal to 50. Do we need some other information? No. So S21 is equal to 21 by 2, which is n by 2. We are simply substituting the values. So 21 by 2 into 2 times a, that is 2 times 100, plus n minus 1, which is 21 minus 1 into d, that is 50. D is 50 here, right? Okay, so 21 by 2 into 200 plus 20 into 50. Again, instead of multiplying 20 and 50, we are going to do this 2 into 5, which is 10. Okay, so S21 is equal to 21 by 2 into 200 plus then 10 and 2 zeros. Okay, yeah, so 21 by 2 into 1200. Okay, then we are cancelling this and this, so this is going to be 600. I mean 1200 by 2 is 600, and then the final answer, you are going to multiply this 21 and 600 and you are going to get 12,600 as S21. Or this is the answer for the question, that is how much money will be collected in the money box by the time her daughter is 21 years old. Okay, this was about the first equation. Not this one, this one. What about this n by 2 into a plus an? Let's consider that equation. Sn is also equal to n by 2 into a plus an. Okay, so let's use that. Sn is equal to n by 2 into a plus an. Right? What is n? We are going to find the 21st term. Not the 21st term, the sum of first 21 terms. So n is going to be 21. And what is a? A is going to be 100. And we don't need d here because in this equation we don't have d. What is an? Replace n with 21. So we already got 821. Right? We got this value. We have the value with s. So let's substitute that value over here. So S21 will be equal to 21 by 2 into a plus an. Okay, simply substituting the value of a and an. So this is equal to 21 by 2 into 1200, again doing the same step, you are gonna get the same answer. See, here it was 21 by 2 into 1200 and 12,600 we got. Here also 21 by 2 into 1200. So 12,600 will be the total money. Okay, this is rupees. This is also rupees and this is also rupees, because we are calculating the amount of money, right? So this is gonna be the amount that mother deposits on her 21st birthday, and this is the total amount that is gonna be deposited in the money box at this or this on this 21 years. Okay, a period of 21 years we are considering, and the total amount of money that will be collected in this money box. Okay, so you can use the first equation or second equation. So this equation can be used only if the nth term is given, and we have one more equation, that is if an is the last term, that is n by 2 into a plus l. So this is all about this chapter, and through the single question we just completed this whole chapter. So we just have two important equations from this chapter, and for the second equation we have got two different forms, okay, or three different forms. And that's it. See you all on another video. Until then, bye bye.